Hi friends, I myself Dr. Adarsh Mangal, working as Assistant Professor, Department of Mathematics, Engineering College Ajmer. Today we'll discuss about nonlinear partial differential equations of order 1 with a special context to Charpit's method. General method of solution, Charpit's method. This method is advised when the given differential equation cannot be reduced to any of the standard forms as discussed before. We have studied about standard form first, second, third and fourth to solve non-linear partial differential equations of order 1. Working procedure to apply Charpit's method. The first one is, after transferring all the terms to left hand side of the given partial differential equation, denote it as function f involving x, y, z, p and q is equal to 0. Write an auxiliary equation. Please note down, it is an important backbone of the method. It should be kept in mind that the auxiliary equation must be right in all context because it involves partial derivatives with respect to x, y, z, p, q. So that auxiliary equation is dp upon del f upon del x plus p del f upon del z is equal to dq upon del f upon del y plus q del f upon del z is equal to dz upon minus p del f upon del p minus q del f upon del q is equal to dx upon minus del f upon del p is equal to dy upon minus del f upon del y. Now put the values of partial derivatives of f with respect to x, y, z, p and q. Means del f upon del x, del f upon del y, del f upon del z, del f upon del p and del f upon del q into the auxiliary equation. Now obtain a relation between p and q by solving two proper fractions out of these 5. Now find p and q by solving the given partial differential equation with this relation obtained in the step 4. Now put the values of p and q in dz equal to p dx plus q dy. Now we can get the complete integral after integrating the fact. Let us take some examples to illustrate the method. Example 1, solve by Charpit's method, z equal to pq. It is the simplest question based on the Charpit's method. Now transferring all the terms to left hand side, we have z minus pq equal to 0. Auxiliary equation you will have to write. Now del f upon del x here is 0. Del f upon del y 0, del f upon del z is 1, del f upon del p is minus q, del f upon del q is minus p. Putting all these values into auxiliary equation, we have dp upon p, dq upon q, dz upon 2pq, dx upon q, dy upon p, df upon 0. Now to find a relation between p and q, we take first two terms. dp upon p is equal to dq by q. Integrating it, we have log p is equal to log q plus log c. Here it is written log p plus log q is equal to log c. By mistake, it must be log p is equal to log q plus log c, so that p is equal to cq. Now putting the value of p into 1, p is equal to cq, putting into 1, we have z equal to p q means cq into q, cq square, or we can get q is equal to root z upon c. By putting the value of q into 1, we have p is equal to root cz. Now we have dz equal to p dx plus q dy. Now p here is root cz, q is root z by c. After integration, you will have 2 root z is equal to x root c plus y upon root c plus b. That is your answer. Now another example is p square plus q square y is equal to qz. Now auxiliary equation and then partial derivatives of f with respect to x, y, z, p and q. Putting the values of partial derivatives into auxiliary equations, we have dp upon minus pq is equal to dq upon p square is equal to and so on. Now taking first two terms, we have p dp plus q dq is equal to 0, or after integration you will have p square plus q square is equal to 2 into some constant, and we are taking 2 into some constant here is c. Now if we put p square plus q square is equal to c into the given equation first, then we have qz is equal to cy. Qz is equal to cy. And if we put q is equal to cy upon z into 1, then we have p is equal to root c minus c square y square upon z square. Now by putting the values of p and q into dz equal to p dx plus q dy, we have, now the integration is important here is, we have to put p and q in dz equal to p dx plus q dy. Now z dz minus cy dy upon root z square minus cy square is equal to root c dx. Now we have to integrate this. To do so, we have to put z square minus cy square is equal to t square, suppose. So that z dz minus cy dy is t dt. So after integration, you will have z square minus cy square is equal to x root c plus b whole square. Thanks for being with me.